Hello. So this is chapter 2, section 1 of the Algebra Trigonometry book on graphs of equations with two variables. So in the past section we talked about plotting graphs of equations on the number line with only one variable. For example, we plotted before x is greater than 3 on the number line, in that if we have 0 right here, here's 3, we would use an open circle. So that would be how you would plot graphs in the one dimension with one variable. But now we are going to be graphing equations. So for this first example, we have the equation 2x minus 3y equals 15. So now there's going to be two different variables that will have two values that would make this equation true. So in order to satisfy this, we need to find values for both x and y. So to do that, we will take a value for x and find the value for y that would call, or the opposite, that would prove it to be true. So for instance, if x is equal to 9, then we would substitute in 9 for x and solve for y. So we would first start with 2, substituting 9 in for x times 9 minus 3y equals 15. Then we would have 18 minus 3y equals 15. Moving the 8 over, we'd be left with negative 3y equals negative 3. And then y would equal 1. So we have two different values for x and y that prove this equation to be true. So we have x equals 9 and y equals 1, and we'll write this as what's called an ordered pair, which is used as a parentheses, and we use the x coordinate first, which is also sometimes called the abscissa. So we would write that as 9 comma 1. The y coordinate is also called the ordinate, and that is always given second. So the solution set of an equation with two variables is going to always contain ordered pairs, and there's going to be an infinite number of ordered pairs that prove that particular equation to be true. So to show that, we have to graph the ordered pairs in a two-dimensional plane. So to graph this particular equation, we would have a graph which would have an x and y axes. You should always label your axes. And then to plot this ordered pair states that it is positive 9 in the horizontal direction and positive 1 in the vertical direction. So it's going to be somewhere around here. So that would be how you would plot this point in the two-dimensional plane. Now, you may remember that this coordinate system is sometimes called a Cartesian coordinate system, which is named after the French mathematician René Descartes, who lived from 1596 to 1650. So that concludes this intro section to chapter 2. In the next section, we're going to go much more in depth to the graphs of functions, and we're going to look at linear functions as well as some of the terminology associated with that.